Hi everyone. I will solve this problem uh, using DFS. If you go and see on solving the problem using DFS, a lot of people are facing the issues, and I also did. There are few tricks that we have to apply to make it work using DFS. With BFS, we can solve this problem. So this whole video is not is to tell you how to make your DFS solution work with the tricks that I have learned using the reading the solutions here only. I've got the reference from basically top three solutions. I will add the link to those three solutions, helping me understand the DFS solution in the description. And yes, let's start. So let's do this, and let me write it. This is all about making DFS work for this solution. So what I'm going to do, I'm getting the length of the rows, getting the length of the columns, and here I'm going to do what? I am going to return helper. Instead of that, I'm going to do DFS. Uh, I will go with. So what doing here is, here this is a grid, let's say, and in this grid we have to basically tell the shortest path from the top this column to this column. Okay, so what we can do, we'll go from this direction to this bottom up approach. Okay, so here what we are going from m minus n minus 1 to the last this cell to this u0 cell. So here I'm passing m minus 1, n minus 1, and the grid. And also I have a restriction also of that we can eliminate up to k obstacles. So I'll pass the k obstacles also. Okay, so I'm going to do this, defining this function which is returning int, and it is doing this total row, the current column, the obstacle elimination left for us to do, and the grid. Okay, now what do we do? Since we are how many directions we are allowed to move? We are allowed to move in up, down, left, right direction. Okay, so what we can do, from here I can move to this direction, up, left, right, down. From here I can move up, left, right, down. Sorry, up, left, right, down. Here you see, if from this cell, if I move to down, I'm moving to the same cell. Okay, so here I need to track the visited cells also, and not to visit again in the same path. Understand? So for that, what we are doing, I'll use a boolean type visited uh, array, and the size would be m n. Okay, and here I'll pass visited. Here I pass visited, and visited is a boolean type two-dimensional array. Grid is a uh, int type two-dimensional array. Okay, so yes, sorted. What do we do? The first thing that we need to check is, at every position we have to move in how many directions? We have to move in 4 directions. So what are we going to do? We are going to simply take a direction array. Okay, and do what? uh, Pass here. This is the better version of doing the mapping to the directions. 1 0 minus 1, you'll understand what I'm planning on doing. And here I'm getting the minimum ways. So for example, from here I'm moving to all the 4 direction. I will proceed to the previous cell, which will give me the result of minimum ways, because you want to yield the shortest path. Okay, so minimum ways, it is going to be, I'm taking max value. Okay, so what I'm doing, I'm taking a direction, iterating through all these directions, and it will start from 0, and direction will go to 4 directions, direction plus plus. Here what I'm doing is, I am calculating the steps as in the minimum steps required at this to reach from up to this cell, steps required to reach from up to this cell and all the four directions. So what I'm doing, I'm doing DFS get the row, let's say sorry, previous row will be uh, current row plus x direction minus direction. In x direction it will be in previous column will be column plus y direction will be direction. Here what I'm going to, if you iterate, it is for example this direction, it is going to be row plus 1 column plus 0, it is going to be row plus 1 and column will be as it is, so it will be next row. This will represent the down direction, first cell. And if we do this is going to be row plus 0 column plus, for direction equal to 1 for first index, row plus 0 column plus 1, which is going to be the right cell. This is same way we'll iterate the other two directions. So a cool way of representing or iterating through all the directions. Now the steps would be to get the steps from the previous row and previous column and k visited and grid. Okay, okay, this is all that we have to do, and that's it, right? And we will do minimum of math dot minimum. How many whatever steps we'll get, we'll have to go to the proceed towards the one which is yielding the minimum result. So we'll do this minimum and steps. Okay, and we'll return this minimum. Okay, simple function. Now let's address the base cases. Base cases would be, what if the cell is not valid? So for that it could be here, if for example here, if I'm on this cell and moving towards the left, so left will be row minus 1 will be 0 minus 1 will be minus 1. So in that case this will take care of all the invalid rows and columns or cell. So it will be row grid dot length column grid 0 dot length. What we'll do, will return the maximum number, so which represents that it is not valid. And why maximum? Because here we are taking the minimum. So out of returning all the maximum, if even one is returning anything, we'll go towards that. That is why we are taking to the maximum thing to return. Okay, next is, what if we reach the last cell, which will be 0 0. We are starting from here, we'll reach the last cell, we'll simply return how many steps we have taken, 0. And here, okay, now what else? And here, sorry, after doing all of that we are taking one step, no, so we'll have to do this, number of steps will be 1 here. Now what else? I told you that we can possibly visit the already visited grid cell. So what are we going to do? We are going to check if this row column is already visited, will return value. Okay, that it has been visited, don't go there. In the same path it has been visited, don't consider it, because this is going to yield the maximum result. Understood? Now there is one more case. If you see, 0 represents empty, 1 represents obstacle. So if grid row and at this column is equals to 1, it is an obstacle. We can eliminate the obstacle as it says, but how many times? K times, right? So and then we'll check if k is equals to 0, we cannot eliminate further, so we'll simply return integer max value. Okay, simple, sorted. Now what are we going to do? We are going to simply run. But what if I'm at this position? Let's say I'm at this position and all of the further there are obstacles only and we cannot eliminate, and in that case it is returning maximum only. So here, do we need should we increase the steps count? No, because then we will not move further. For example, here we cannot move further after eliminating this also, we cannot move further, right? Here at this cell, if we have eliminated, we cannot move further, so in that case we cannot take further steps. So here we are checking if min is equals to integer dot max value, min is not equals to integer dot value, min is equals to add the min, and just return it. Okay, now run it. Let's see if it is going to work. Sorry, it is going to min ways, no? mm, int visited will be, let's call it visited. Okay, 24, which is 24. Yes, we've got to add one thing. If steps, sorry, yes, for example, for this, we are not decreasing the count here anywhere, right? So we have to, what if grid row and if this column is a obstacle, we'll simply do what? Subtract it, right? We'll simply subtract it, right? So let's do this and then run. Hmm. Okay, also what we are doing, we are checking here, but we are not marking anything as visited. So we have to mark the cells as visited also, right? So this row, this column is equals to mark it as true, and then because since we are, it is a backtracking problem also. In the same path, we want to check with that we are not visiting it again. So once we have marked it, we have to uncheck it also. So here, like a normal backtracking problem, we are marking it as non-visited in the same path so that it can be used in the other path. Time limit exceeded. Let's remove this. Reset the basic these two examples and see if it is working or not. Okay, so this worked, it returned correct output, and it did not, it returned the maximum. So here we can check if it is returning maximum result. Just return, sorry, I say shortest path will be this answer. Okay, we are saying if shortest path is equals to the maximum number, return minus 1, otherwise the shortest path. Let's see if it will work or not. It is working. Now what we can do, we can do memorization, because this seems to be a TB problem and this is how we are doing it, right? So let's memorize it. No, memorization. Okay, so I'm taking, if you see, we are iterating through three things which are dynamic, changing: row, column, and key. So we'll go and memorize all those three things. New, it is going to be n k plus 1, because we are passing here k value. So we are going to do initialize it with with fill dpi j with what? Integer dot max value, because what default value are we taking? We are taking integer dot max value here as default, so we are taking that only. We have filled it and we are going to memorize it dp, and here we are int three-dimensional array, and here what we are doing, we'll pass the dp. Now to memorize it, what we'll check if this row, column, and at this k value is not equals to integer that max value, which means it has been already evaluated. I'll simply go and return it. Okay, and here also I'm going to save the result. Understood? Let's run it. Now let's save it. Let's submit it and see if it is going to run or not. See, it is throwing this time limit exceeded error on, which is the test number 29. What we can do here, two things. First is we can apply a technique, a technique trick called Manhattan optimize distance optimization. What is Manhattan distance? Is in a grid. Let's say it in a grid, 0 0 0 0 0 0. Let's say this. In this the grid, if I want to evaluate the distance between this point, between any two point, let's say it is going to be x1, y1, and second point will be x2, y2. So the distance in a grid between two points is going to be um, x2 minus x1 plus y2 minus y1. This is going to be the shortest distance between two points in a grid, and this is what the Manhattan distance is. Now there is one thing is, when can we take it? We can take it only when there are going to be no obstacles. That is why it is going to take the shortest distance. Or and when we have like the number of eliminations greater than the total distance, this distance that is going to come. In that way we will at most eliminate all these path, that is this all these cells that will encounter in the shortest distance, and we'll reach the starting point. Now that's, let's say the row and column will be for, if we apply the Manhattan distance here, it is going to be row minus 0, because the starting point we have to reach is the 0th cell, plus column minus 0, which is going to be row plus. So the Manhattan distance, the shortest distance proven between two points, will in a grid. In our case, will be so row plus col, because we are the starting point is the 0th cell. But if it will be when the k, the elimination will be greater than the path, which is Manhattan distance. So we'll call it Manhattan distance will be row plus column. Okay. So here we'll check when the Manhattan distance shortest is greater than the, when the k is greater than the Manhattan distance or equals to, we'll simply return the, save it, first memorize it and return this Manhattan distance. Cool. Let's run it. Working. Let's see. In this case it was not working. See, it has worked. So this solution has worked. Okay. Um cool. So this is all about making it this thing work. Also, if you see, one more thing I'm seeing people commenting is that make the left turn first and then the right turn. Here I did it wrong, but even then it worked. But if you do that, maybe then you can also improve the performance. So that is one more approach, but the only trick here is to use the Manhattan distance, and then that way it is going to not throw the TLE, and even DFS is going to work. Thank you.